Problem number 9. Solution for this problem you can find by a reference under this video in the description. A spring has an equilibrium length of 2 meters and a spring constant of 10 newtons per meter. Alice is pulling on one end of the spring with a force of 3 newtons. Bob is pulling on the opposite end of the spring with a force of 3 newtons in the opposite direction. What is the resulting length of the spring? Solution. If they pull with a force F, we can find what is total enlargement of the spring from Hooke formula. F equal K dl, where K is spring constant and dl is enlargement. Now we can find what is the enlargement and find what is total length of our spring. That will be initial length plus enlargement, which is 2.3 meters. Solution for this problem you can find below this video in reference in the description. Which of the following changes will result in an increase in the period of a simple pendulum? Let's investigate. We know that the period we can find from simple formula. Period equal 2 pi multiplied by square root from L over G, where L is length of this pendulum and G is acceleration of free fall. Let's investigate our cases. Case A. Decrease the length of the pendulum. If we decrease the length, period will decrease. Increase the mass of the pendulum. Mass is not affecting period. Increase the amplitude of the pendulum swing. So from the first view we cannot say that amplitude has influence on period, but let's do it later. D. Operate the pendulum in an elevator that is accelerating upward. If it's accelerating upward, our effective acceleration of free fall will increase by this acceleration of elevator. It means that the period will decrease. E. Operate the pendulum in an elevator that is moving downward at constant speed. In the inertial frame of reference, we don't have any result influence on period. We can see it from this formula. If we measure period more precisely, we can say that it's equal to this expression. So it means that the period depends from amplitude. For small angles, this function it's almost 2 pi, but it's increasing with the amplitude theta 0. For small angles it's increased slowly, but later after 15 degrees it will increase faster. So it means that amplitude will affect the period. So if we increase amplitude, the pendulum period will increase. That's the solution. Problem number 11. Solution for this problem you can find by reference below this video in the description. A large metal cylindrical cup floats in a rectangular tube half filled with water. The tap is placed over the cup and turned on, releasing water at a constant rate. Eventually the cup sinks to the bottom and is completely submerged. Which of the following 5 graphs could represent the water level in the sink as a function of time? Solution. If we analyze all possibilities, we can say that initially when water is going to this cup, the difference between level of water in sink and in cup will be the constant. So it means that speed of this water level change is constant, and when the level of water reach the top of this cup, it will sink instantly. So it means that level of this water in the pipe will drop instantly. But after that, the speed of filling will be with the water will be the same as before when it floats. So it means that only possibility here we have in case C. Here we have constant speed after it's instantly dropping this level, and after it's going with the same speed as before. And this is the only possibility.